Interrupt.
And Mrs. Flynn.
Today I'm thinking about train tracks.
Train tracks? Why are you thinking about train tracks?
Well, because we're talking about parallel lines, and when I think about train tracks, I think about parallel and them never touching and going in the same direction.
So let me guess, are you thinking something like this?
Indeed I am. So how did you do that? How did you get those to be parallel?
Well, I noticed in my y1 and y2, I had two equations in slope-intercept form.
Ah, okay.
And one thing that's similar about those two equations is they both have a slope of
2.
2. So parallel lines have the same gradient. So that means that m1 equals m2.
Right, so the slope of the one line equals the slope of the other line. Okay.
What about perpendicular lines?
Perpendicular lines. Well, if they're perpendicular, that means they meet at a 90-degree angle. And so there's an equation there you're putting in there. Let's
What are
see.
you thinking about that? I think about intersections.
Oh, intersections. Okay. Like roads, two roads.
Yeah.
Two roads.
So now if we go back here and we look at our equations in y equals mx plus b, those are actually opposite reciprocals.
Right. So we flip the fraction upside down.
Slope is opposite reciprocals.
Right. So
So
opposite meaning opposite sign, right? So you change
Yeah.
the sign.
So let's see, if I had, for example, a slope of 2,
Okay.
the opposite reciprocal of that would be negative 1/2. So if I multiplied those two together, I would get negative 2 over 2, which is
-1.
negative 1. So we know that our gradients are perpendicular if m1 times m2 equals negative 1.
All right. So give me an example. Let's see if you can trick me.
I have a slope of negative 7.
All right. So if I want an opposite sign, so I'm going to change the negative to a positive. So I want positive, and I'm going to flip the 7. If I flip the fraction, a reciprocal would be 1 over 7.
All right, now if I multiply those two together, I get negative 7 over 7, which equals negative 1.
All right.
I'm happy.
Hooray.
That shows perpendicular lines.
Okay, so let's see if we can use this somehow.
Okay, which of the lines, y equals 4x, y equals 3x plus 2, and y equals x is perpendicular to this line?
Ooh. Well, I need to, if I'm going to find the perpendicular, I need to look at their slopes, because I want the slopes to be opposite reciprocals.
Okay, so the slope of this line, that one's easy. It is 4.
Okay.
This one,
3.
this one, don't be tricked.
Oh, I want to say x, but you said don't be tricked, so it's got to be 1 in front of the
1,
x.
The coefficient of your x variable.
Right.
All right, and the last one, if we're looking for it to be perpendicular, that's a symbol for perpendicular, to this equation,
Right.
we should probably evaluate that equation.
Right. So we find the slope.
What's an easy way to identify slope? When we're in slope-intercept form.
Y equals mx plus b.
Then I can identify my slope.
I think and y equals mx plus b is like music.
Oh, because m is slope?
Because m is slope, I think. Yes.
All right. So let's just go ahead and subtract x here. So now I'm left with 4y plus 2. I'm trying to isolate my variable y equals negative x.
And subtract the 2.
4y equals negative x minus 2.
Divide by 4.
So we have, what is really in front of this x? Don't be tricked.
A -1.
Negative 1/4 x minus 1/2.
And so if we're looking for perpendicular, it means we're looking for opposite reciprocal. I'm trying to do sound effects.
You're a funny guy today. Okay, so slope is negative 1/4.
Right. And we want opposite reciprocal.
So what's our perpendicular slope?
Okay, well, if I take -1 over 4 and I reciprocal, that's going to be 4 over 1.
positive 4 over 1, which
Right.
is the same thing as
4.
Now, going
Change the
back
sign.
here,
That's the y. It's the same as 4. That's the first one. Y
There we
equals
go.
4x.
so our answer is y equals 4x. Okay, that's it for today. Or for this one.
Right.
not
There'll be
for
another one,
today.
of course. They never stop.